Welcome. So we're going to talk about how to graph a cosine function now. So we have here, this is what we're aiming for. F of x equals -3 cosine of the quantity x minus pi over 6. And we have this standard form I've written here in the upper right. F of x equals c plus a cosine of b times the quantity x minus d. So this is where we're at, kind of the basics, and I just want to draw a sketch over here to the upper right. What does the cosine function look like? Well, when your angle theta is 0, when we're at 0, x equals 0, cosine is equal to 1. So we start at 1, we go down to 0, and then we have our nice little graph that looks like that. So that's my little sketch of what the basic cosine x function looks like. And that helps me get something to build off of. So let's go over here. We're going to start by graphing, I'll give it a different name, g of x equals -3 cosine x. So we're not doing anything with the interior. We're just going to handle that cosine x. Now, something about this is that this number in front, this coefficient in front of the cosine, that is the same as the a value. Now, this gives us our amplitude. So our amplitude will be 3. But the other thing that it does is because it's a negative value, it causes the entire function to reflect over the x-axis. So everything that's above the x-axis is going, like if it closed a book over the x-axis, everything's going to get copied to the other side and flipped. So let's go ahead and draw what that will look like. I'm going to start here with my x and y axes. And I'm going to draw kind of, I'm going to sketch out what the original cosine, what cosine 3x will look like, I guess, is what I'm saying. And then we're going to flip it. So I'm going to use it in green here. So cosine of 3x is going to be like this. Okay? Now, what I need to do is flip it. So I'm going to mirror that like this. All right. It helps if you make sound effects while you're doing it. All right, so this is cosine, and I'm going to go ahead and see if I can just carefully go in and erase some of this green. So that's what I would do if I were solving this problem as a student. I would write it out in pencil, sketch it with my, just my dotted line on my pencil, and then go back in and erase some of it so that I have a cleaner function. All right, so now this is what it looks like. This is my cosine. Now you've noticed I haven't labeled it, and it really just looks like the same. So how have I changed my amplitude? Well, see, the beauty of drawing your own is that you can just tell it. You can just say, oh, this is +3 and that's -3. I'm done. So you don't really have to make it harder to draw. Just draw it as it is, and then alter your labels to accommodate the change. So that's the first component. Let's go ahead and continue. So if I'm comparing this original function to my standard up here in the black in the upper right, I don't have a c value, so there's no vertical shift. I've already handled the amplitude and the negative, which causes me to flip over the x-axis. I don't have a b value. There is no coefficient in front of my x. All I have is d. So d, that is your horizontal shift. So that's where you are shifting to the left and to the right. So actually, now that I've done this, I'm pretty much done. I'm just going to go ahead and graph the last component, which is f of x equals -3 cosine of x minus pi over 6. So, oh, and I apologize. On this first graph up here, you are usually asked to give some indication of where your points are. The function cosine has a period of 2 pi. So I know that I'm going out to 2 pi over here. I know that this point, my halfway through my cycle here, that's going to be pi. And for most instructors, that's going to be fine. Maybe they want you to indicate where it touches the x-axis. If they do, then you're going to need to indicate that as well. Pi over 2 and 3 pi over 2. But for me, as long as you're clearly indicating me that you know that the period is 2 pi, I'm happy. Okay, now let's proceed. So I have this -pi over 6. That's my horizontal shift. The way that these work is that it's kind of opposite of what you think, right? So you think that it's negative value. We associate negative with moving to the left, but this actually shifts my whole function to the right. So I'm moving pi over 6 to the right. So that is my phase shift. This is referred to as the phase shift. So I need to draw that. So to be a little bit careful, let's go ahead and start. I'm going to draw my x-axis here. Oops. Try to draw it a little straighter. I'm going to give myself a little space so I have equal on the right and the left. So I'm going to draw my x-axis here and my y-axis. I know that I need to shift my whole thing pi over 6 to the right. And, in this instance, maybe it is really good that I went ahead and labeled this point. So the place where my function is going to touch the x-axis first is going to be pi over 6 to the right of pi over 2. So let's add them. Let's say pi over 2 plus pi over 6. Well, I need them to have the same denominator to to add them together. So I will change the pi over 2 to 3 pi over 6 plus pi over 6. That's 4 pi over 6, which you can simplify to 2 pi over 3. Okay, so in somewhere, if this point here is pi over 2, I'm moving a little bit. So I'm going to put my point instead. I'm going to get rid of that dot. I'm going to put my point here, just a little bit to the right. And I'm going to call that point 2 pi over 3. And then I'm going to go ahead and start my sketch. So I want my point to hit its lowest point here. It's going to cross the axis here, and then I'm going to have my nice curve there. All right. So again, if you're graphing these by hand, it's hard to get perfection, but do the best you can in terms of making it look fairly neat. I know what my amplitude is. It's 3. So I'm going to do the 3 and the -3 here. And then what I'm looking for next is indicating some other points, right? So this, kind of peak here, it was at pi in my original function. Now it's pi over 6 to the right. So pi plus pi over 6. Well, pi is 6 pi over 6. I'll write that in like that. And so what I end up with is 7 pi over 6. So I'm going to go ahead and label that point, 7 pi over 6. And then we can label some of the other points as well. Again, each of these points is the point from the original graph plus pi over 6. So that is how we handle graphing this new function, this -3 cosine of x minus pi over 6. Thank you so much.